Okay, now let's look at inverse variation. Suppose A and B are variables. We say that A varies inversely as B, or A is inversely proportional to B, if there's a positive constant K such that A equals K over B, K divided by B. And again, K is called the constant of variation. Now, again, we use Y and X very often, so we could rewrite this as Y equals K over X. Okay, that's inverse variation. Now, one thing I want you to recognize about inverse variation is that we could rearrange this equation by multiplying both sides by x, and we get yx equals k. So notice that when you multiply your x and y, you always get this same constant k. Okay, the product of x and y is constant. Okay, now let's look at an example. Y equals 24 over x, so that has the form y equals k over x. So y varies inversely as x, and notice that the k, the constant of variation, is 24. And so this has this form, y equals k over x. Or we could rewrite this, okay, y equals 24 over x as xy equals 24. Okay, so the product of x and y has to be 24. So for example, when x is 4, y would have to be 6. Right? Go back to the original equation. If you plug in 4 for x, y would have to be 6. Now, see what happens when we plug in x equals 2. Now, notice here we're taking half of our input. What's going to happen to our output? Are we going to get half the output? No, that would be the case if we had direct variation. It turns out we're going to get double the output, double the y. When x is 2, y will be 12. Okay, and vice versa. If we were to double the input, we would get half the output. So if we were to double 4, we would get x equals 8. What would y be? Well, y would be 3, half as much as 6. Okay, so notice that if we were to triple the input, we would get 1/3 the output, right? If x were equal to 12, that would be tripling 4, we would get 1/3 the output. We get y equals 2. But notice that in all of these cases, 12 times 2, that's 24. 8 times 3 is 24. 2 times 12 is 24. We're always getting the same product of 24. Okay, so that's one property that inverse variation has. Now let's look at another example. Suppose y varies inversely as x, and that y equals 5 when x is 1.5. Find the variation constant and an equation of variation, then find y when x is 3. So notice we have inverse variation, so it's y equals k over x. And we're going to plug in 5 for y and 1.5 for x. Now we can multiply both sides of this equation by 1.5. We'll get 5 times 1.5 equals k. And 5 times 1.5 is 7.5. So that is our variation constant. Okay, our equation of variation will be y equals k over x, but we found our k to be 7.5. So this is our equation of variation. Okay, now the question is, what is y when x is 3? Well, again, we could plug things in and find y, but notice that we're doubling our input here. If we put 1.5 in for x, we got 5. Well, if we double the input and put 3 in, we should get half the output. We should get half of 5, which is 2.5. So our final answer should be 2.5, but let's plug things in. What is y when x is 3? So we're going to plug in 3 for x into our equation of variation and try to find y. Well, 7.5 divided by 3 is, in fact, 2.5, just like we guessed. Okay, now let's look at a real-world example. The time required for bricklayers to build a certain park wall varies inversely with the number of people doing the job. It takes 10 bricklayers 4 hours to build the wall. How long will it take 8 bricklayers to do the job? Now let's think, is it going to take more than 4 hours or less than 4 hours? Well, we have fewer workers. We only have 8 workers, 8 bricklayers, so it should take longer to do the job. So I would expect our answer to be more than 4 hours, maybe 4.5, 5 hours, 6 hours. How long? Well, let's figure it out. Okay, now we have to define some variables. So let's let y be the number of bricklayers. By the way, you don't have to use x and y. You could use maybe b for number of bricklayers. And we'll let x be time. You could maybe use t for time. But let's just keep using y and x here. So we have y equals k over x. Okay, because we're told it's inverse variation. Now we also have that y is 10 when x is 4. So we're going to plug in 10 for y and 4 for x. And notice that if we multiply both sides by 4, we're going to get k equals 40. Now what this is really telling us is that it takes 40 man-hours, or person-hours, to do this job. Okay, so how long will it take 8 bricklayers to complete the job? Well, let's plug things in. We still have our y equals k over x, but it's actually y equals 40 over x. But this time, we're told we have 8 bricklayers. We're told that the y is 8. Okay, so we're told the y is 8. So the question is, what is the x? Well, we have 8 equals 40 over x, and you can see that x will be 5. This really gives us 8x equals 40, and so x is equal to 5. Now, what is that? Is that 5 bricklayers? No, that's 5 hours. Okay, it takes the 8 workers 5 hours to complete the job. Whereas if you had more workers, you had 10 workers, it takes less time, obviously, to do the job, only 4 hours.